There have been two new tool types added for PowerMill 2014. These are barrel tools and dovetail tools. Both of these tool types can be used with all strategies like existing tools in PowerMill. In addition to these new tool types, there is also several other enhancements to the tool functionality, including the ability to add different upper and lower tip radiuses when defining a tip disc tool, and also an enhanced and enlarged tool assembly view, making it easier to view a tool holder profile, for example. Let's just have a look at these new and improved tool functionality on the example project. The first thing we're going to look at is the new barrel type tool. So under the tool functionality, when we create a tool, you can see there's a new entry for barrel, and then we have all the parameters we use to define a barrel shaped tool, including diameter, barrel radius, upper and lower tip radius, and the Y offset for the center of the barrel radius. Once we've defined our barrel tool, and I have one I've created previously with a shank, then we can utilize that tool for all strategies in PowerMill. So here's an example of a blade finishing strategy using a barrel tool. This is a typical example where you would use a barrel tool. Barrel tools are often used in the aerospace industry where we have large sweeping concave or convex radiuses. And the barrel tool allows us to use a much bigger step over than we would with a ball nose tool, but still maintain a very small cusp height and good surface finish due to the large side radius of the barrel tool. So here we've used a surface projection technique with a reference surface which is highlighted, and we're using a spiral pattern to machine that surface with a lean angle of 85 degrees. So we're actually using the side of the barrel rather than the end of the barrel. So if we simulate that from the start, slow the simulation down and then play, you can see the effect the barrel tool will have on the surface finish. Because we're using the side of the barrel, which is a large radius in comparison to, say, a ball nose tool, it allows us to have a much bigger step over while maintaining a much smaller cusp height. The second new tool type is a dovetail tool. Again, here's one I created earlier. If we just have a look at the settings page for the dovetail tool, again we have overall diameter, lower and upper tip radius, overall length of the dovetail, and the taper angle. So with this tool I've used to machine a dovetail slot, locating slot on the side of these blades. So for this strategy, for this toolpath, I've used a swarf finishing strategy, and you can see the surfaces highlighted that we are swarfing. Just a single pass at the bottom of the surface, and again we can animate that, simulate from start, and then just a pass going through either side. In addition to the two new tool types, we have improved tip disc tools. If I create a tip disc tool, Now you can see we have an upper and lower tip radius, whereas before we only had one radius. So maybe have a lower radius of 4 and an upper radius of 0.5, for example, like so. And finally, the last improvement is an enhanced assembly view. If I go back to my blade finishing toolpath and just draw the holder associated with that and go to the settings page, you can see here we have a tool assembly preview. So this allows us to have a much bigger view, which is ideal when we want to check against the tool holder safe profile. So we can zoom in on that view and just pan that view down, and there we can see the tool holder safe profile and my shank. I could actually make my shank a little bit shorter if I wanted to, this lower section, maybe make it 85. And you can see now the shank actually violates the safe holder profile. So 85 is a little bit too short. Let's make that, say, 87. And there we go. So it's much easier to build our tool assembly and zoom in when the tool holder profile is displayed.